In cryptography, a secret sharing scheme is a system that allows an individual, known as the dealer, to share a secret number with various people in such a way that no one person knows that number, and a specific number of people must come together to discover the secret. Suppose the owner of Coca-Cola stashed their secret formula in a safe that can be opened by typing a numeric password. There are 4 executives at the company, and 3 of them must collaborate to open the safe. So the owner, or dealer, created a polynomial whose y-intercept is the secret number, or password. Then, each executive was assigned one of the following points: 1, 115, 2, 112, 3, 99, and 4, 76. The first question we might ask before we can find the secret formula for Coca-Cola is, what is the degree of this polynomial? Before we can even talk about coefficients or y-intercepts, anything like that, what is its degree? Well, if 3 people are needed, and 3 people or 3 points uniquely define the polynomial, then its degree is equal to 3 minus 1, so 2. It's just going to be a quadratic function. And it might seem obvious looking at the big picture that the y-intercept is somewhere around 100. But remember that each individual person only knows 1 point. So as far as they know, this parabola could be flipped upside down. Now, to find the secret password and get the secret formula for Coca-Cola, we need to know what the function is that the dealer created. And to do so, we can use just 3 of the 4 points. So we'll just get rid of the last one, and to find this function, we're going to get its coefficients using a matrix. Now what we're going to do here is use the x values in the column associated with x to the 1, because x to the 1 is just x. And it doesn't really matter what order we put them in. I'm going to put them in the order 1, 2, 3. Now, the order of these columns should be essentially the order of a standard form polynomial. So x to the 2, then x to the 1, then x to the 0. Now, you could change the order of that as well, although I recommend being consistent with the order you pick. So after you do that, you have the x values, then all you need to do is square them to get the first column. That is just x squared after all. So 1 squared is 1, 2 squared is 4, and 3 squared is 9. You may be wondering what we put here in the column for x to the 0, and it might be as simple as it sounds. Any number to the power of 0 is 1, so we are just going to put a 1 in every column. And that essentially represents the fact that this c, this constant in the polynomial, is being unchanged by x. I'm going to make this 9 look a little better as well. That's bothering me. Alright, well, I don't know if I did much justice to it there. But finally, the last column you'll have in the matrix will be your y values. So we have 115, 112, and 99. Make sure you are keeping these in the order you've chosen. So with the x column in particular, we have 1, 2, 3. So I'm just going to put these in the order 115, 112, and 99. Now, finally, to get the actual coefficients, a, b, and c, we need to reduce this matrix to echelon form, and that can be done using a calculator or a computer. On the TI-83 or TI-84 calculator, you'll enter the matrix first using a matrix button. So that button is located right here, and after you enter the numbers on the screen, you will then use the command rref and reduce that matrix to echelon form.
Now in that last image we were looking at a TI-83. This is an 83 plus, and in this case the matrix button is in the first column using the second option in yellow. So you don't actually see the word matrix written on a button, but if you look at x to the -1, the word matrix is right above it in yellow, so you would just hit second and matrix, and that should bring you to this screen right here. Now you can enter your matrix as matrix A. This is just to give it a name. You're going to go over to edit, and we'll edit matrix A. Just hit enter. We'll want ours to have 3 rows and 4 columns, so enter 3, hit enter, and then 4, hit enter. And one of the columns we can't see, it's represented by the little horizontal lines. So go ahead and enter the matrix as given. Each number, you'll just type it in, and then hit enter to move on to the next column. You can also use the arrow keys to navigate, so I could put in the ones that are at the top just by hitting 1, enter 1, and then this brings me to the last column, enter 115, to make it just as the matrix that we saw earlier, and then we could enter here 4 and 2 and so on, but notice we can also use the arrow keys, so I can put in the 9 here, for example. So now I've put in all the entries of my matrix. I'll need to quit back to the home view, so hit the second option again, and then quit is written right above the mode key. So now we've quit back to the home view, and we'll want to use the matrix option and do some math to it. So hit second, go back to matrix, this time go to the math option on the top, and the command is rref. Just use the arrow keys to scroll down, you'll find it right there. Ref is close to the same thing. There's an extra step required if you use that, so rref gives you the answer directly. Go ahead and hit enter on that, and then second matrix again, because we need to tell it what matrix we're going to reduce. In this case, matrix A. Notice this is 3 by 4 there, so that's the one we just entered, and then hit enter one last time so it calculates it. Now, finally, we're looking at the coefficients for that polynomial. -5 is our value for A, 12 is the value of B, and 108 is the value of C. And you may remember that the password to the Coca-Cola safe was the y-intercept of the polynomial. And now we can see that the password is 108, 108. Okay, not a very secure password, but of course a small example just for demonstration. Next we'll look at one more interesting question related to this whole secret sharing scheme idea.
So you might wonder, what if a new 5th executive joined Coca-Cola? How would that new person be assigned a point? Well, you can just give them another point on the parabola. In other words, the dealer could just take any x value other than the ones already assigned, 1, 2, 3, or 4, so 5 for example, plug that into the polynomial and get the y value, and then they have an ordered pair that they can hand that 5th executive. So there you have it. A secret sharing scheme that uses polynomials and a really cool application of something that you can learn in high school math. I hope you've enjoyed today's video about polynomials and secret sharing schemes. This particular one was invented by a mathematician named Shamir, who is perhaps best known for RSA encryption, taking part in that along with other mathematicians. Um, well, anyways, I do have other videos on my channel about mathematics, and I hope to see you next time.